Уважаемые коллеги, друзья,
Dear colleagues,
очень рад всех здесь
friends, I'm very happy to see you all,
аудиторию.
and I'd like to welcome our online audience.
Хотел бы поговорить про две,
Um,
с одной стороны, не связанных вещи, но которые в моей голове
so,
сложились в одну очень простую
two things which were not connected.
с вами.
I'd like to share with you this concept.
Быть интересно.
I've asked guys, and I think that
Никакого хардкора,
it's interesting for you. There will be no hardcore, there will be no super difficult
вещей зубодробительных. Расслабьтесь, будет всё достаточно.
things, so please relax. Everything is going to be quite light.
Мы с вами живем в современных инфраструктурах.
So we live in modern infrastructures, they're quite complex, and as a
Работающий в Яндекс.Клауд, сказать,
advocate developer working in Yandex Cloud,
всегда, когда вы
for me it's important to remember,
важно в каком,
when you are working in cloud, you are always working with a
все компоненты, которые вы используете,
constructor.
чем
Everything that you are using, all these components are like bricks, and the better they suit each other,
любой
match each other, the easier it is to work. And it's important that every operator thinks on how to connect so that you may build your own spacecraft, which is going to grow, and you connect bricks to bricks, and then you make a huge spacecraft. So you are constructing your systems, and the way they work, it depends on you.
веду подкаст. И
I have a podcast,
хобби. Кстати, если вы слушаете подкаст,
The Art of Programming,
или иногда делаю опросы, один из таких,
and I'm making some surveys among my
пьют кофе. И вот как
listeners when they relax, when they drive, when they
просто
drink coffee. I had a question in my mind:
event-driven архитектура.
event-driven architecture.
Зачем?
What is it?
Я, недолго думая, спрашиваю,
And I asked my colleagues.
прекрасную книжку. Я такой думаю,
They recommended me a beautiful book, and I said, "Who is reading books now?"
в кайф. Значит, я такой думаю, книга это долго. Может быть,
And book is longer, so I thought that maybe there is something simpler.
что можно посмотреть, почитать. Знаете,
And I looked at different sources that are more interactive.
ссылочки посмотреть.
I've collected them. You can look using this link,
Сократить количество времени на изучение,
and you may
по крайней мере, поверхностно,
reduce the time to study
такой обзор.
10 times.
Но все равно много. Я думаю, ну,
But it's still too much because I'm drinking coffee. I want to make it quick.
такого common sense
So I decided to
как разума спрошу.
ask the common sense
Является, ну, какие-то
GPT.
event-driven архитектуру.
So what is event-driven architecture? And they give a definition which is adequate, which is easy to check. I've checked it in different systems. So briefly, it's an approach
в котором компоненты
in which components,
взаимодействуют друг с другом через
parts of the system, interact through event exchange.
вроде бы ничего.
It's quite simple,
События
nothing difficult. What kind of events?
это какие-то
Events
изменения, которые
are
снаружи или внутри системы генерируются, и
important changes,
некоторого пакета данных
and there is some
некоторый жизненный цикл.
package of data which has its life cycle.
Попадает в систему, хранится.
And it gets into the system, it's been updated,
То есть какие-то функции,
and
события
then
работают. Я такой думаю,
utilized.
event handlers,
And there are some event handlers.
что-то знакомое.
I thought that I've heard about this
Когда пришел в Яндекс.Клауд, я стал заниматься
because when I came to Yandex Cloud, I started to
важной для меня темой сервера.
do a very important thing for me, which is serverless.
В принципе,
And in serverless, everything is about events.
я такой думаю,
It's a
я же этим занимаюсь.
event
Прям
system, and I thought that I am doing exactly this.
если очень
So
общо на это все посмотреть, практически любое
and
приложение, это приложение построено
any serverless application is built on event-driven architecture. You may not know about this, but it's so.
2 секунды у вас украду времени, поднимите руки.
And just 2 seconds, who is using serverless right now or seen some examples? A couple of hands. some few hands I see.
Смотрите, очень важная история сама по себе.
It's a very important story. Just 2 minutes for those that haven't seen serverless.
Дело в том, что сама первая успешная реализация
The first
случилась,
commercial
АВС запускает свой первый сервис, который называется
happened in 2014.
мы берем кусочек,
It's AWS Lambda
да?
by Amazon.
Написали небольшой скрипт,
You can write it in Python, a small script, and then you throw it into the cloud to work at certain address. When there is a user query,
и
it's launched on a small virtual machine, and it's sent to this
и в тот момент времени все-таки,
function.
как же круто, все резко побежали,
And at that time, I thought that how it's cool. Everybody wanted to have this.
подключили, сделали свой
And there is a story. We've done our own service, but a bit later.
сервис вот этого первого базового
Function as a service, the first basic service within the serverless applications, there are three principles. It's abstraction, because we do not own servers. We own a part of code which we operate, which we create and change and put into the
потому что платформа
cloud, automatic scaling, because the platform decides if there are too many queries,
автоматически поднимается в рамках нашей квоты,
too many demands,
инсталляции вот нашего вот этого
then
маленького кода, который мы положили.
it's number of installations of our little code which we have inserted into the platform. And when they are processed, they are switched off, and then some savings that are there. And this was to prevent
Для этого сделано.
chaotic components.
Надо сказать, что, ну,
And I should say that back in 2014, now it's 2025, there are a lot of changes, and there are some archaeological artifacts.
копнуть эту тему прям глубоко, то есть вот в прошлом году вышла прекрасная книжка.
So last year, an excellent book was published, if you want to delve deeper into that. So if you remove the word AWS, here you'll see a description of how it's done everywhere.
Если хочется коротко, потому что мы
So if you want to have it brief,
вроде как нет.
because it's like it appears that there are a few people who read books and others don't. So you can use this link, and Maximilian and Emily will take 45 minutes to explain how we write the code, here how it starts, how we escalate, what the challenges we encounter. Actually, you can take 40 to 45 minutes to see how it's explained. And what they're talking about is like a base. It works the same way for everyone. The only caveat is that they are presenting it kind of an advertisement. Once you start getting deeper into that,
Они как вот слоями.
so you'll see that there are certain myths that have accumulated for several decades. And I mean, I prepared a special presentation to dispel those myths. What's indeed a problem, what is not a problem. And you can watch this, and it will take you like 40 minutes to get updated to the state of the art. Why am I talking about serverless? And what for? There are not so many people who already use that in their infrastructure, but it's important. If we take a look at some cloud layers, so for instance, if you have a traditional infrastructure, so we look at everything from the ground to top. So there's ES and PAS, and we need write only functions.
Так важный момент заключается в том,
The important point here,
параллельно. И каждым годом подсматривают друг
the important point is that all these layers exist in parallel.
перетаскивают к себе. Таким образом, очень интересное явление, я заметил.
And there's quite a curious thing happening over the past 2 years, at least. A lot of large companies build their own platforms,
Сервисы, которые внутрь себя втаскивают.
different PaaS services.
В том числе концепции serverless влияют на то, как они
And this serverless concept affects how they do PaaS.
это внимание,
So if it's possible for you, please take a note. how it's done, because in your large company it may appear as well, maybe a little bit later. Why am I so confident talking about that? Because if you take a look last year and the year before last in AWS, and AWS plays the role of a flagship for us, showing what changes are going to happen worldwide in 5 to 7 years, depending on how technologies are going to develop. Then in roughly one in every two presentations, there's this part. So how it happened, how it was done before, and this is the serverless bit that we inserted. So this is how it's been happening in all major companies. And I must say that a large infrastructure start living on parallel. So they said you deploy from the same repositories and you get such a rich infrastructure. It's clear that to serve a large-scale infrastructure manually, it's something you don't want to do at all. And as a whole, as a developer community, we've long arrived at the need to use some automation tools. And of course, IAC, infrastructure as code tools, come to help us. This is the second part. These tools support us as developers, helping us deploy our infrastructure. Let's go through all of the tools that we use. They appeared in a certain sequence, but if we just run through them and leave your scripts outside, it's obvious that a long time ago it was Bash flying over the waters of the Nile. It stays in your heart, but you want to have some sweet things to be felt. And of course we have, for instance, imperative DSL. These tools appeared very fast as soon as infrastructures became very large and deployed in the cloud. So these things appeared, emerged, we started loving them, but actually one would think that they got obsolete, but they keep being developed and they keep affecting us. And you want to stay on the wave and attract some new practices to your current work, I recommend that you look at what's happening there. And here are references to three great presentations. One of them impressed me a lot, from Pavel Vorobyov. And the question is, even if you don't use them, but these approaches are going to affect you because, as I said about the cloud level, they live in parallel. All tools, all layers, all everything, they live in parallel, affecting each other. So then declarative DSL appeared, the most well-known platform. In a certain sense, we describe the target state, and the framework brings our infrastructure to this target state. Of course, FAPEC is not mentioned here, but nevertheless, they all work about the same. Then other more exciting toolkits appear for serverless, for instance, serverless DSL, providers themselves started developing cloud development kits. It's clear that it's a very convenient thing for integration. These are specialized libraries, in a certain sense, that allow us. It's like a pattern builder, largely speaking. So we have code, we live with it, and it offers us an opportunity to build our infrastructure code next to it. It's very convenient. It allows us building our infrastructure in a unified pipeline, in a certain sense. And then serverless CDKs appeared. But conceptually, none of these was solving our main DevOps problem because, largely speaking, at the end of the day, we wanted to get some closed circuit within which we would write code, not dealing with the infrastructure part. Developers don't like dealing with the infrastructure. They say, so I've written the code, it's ready, it works, so this is the bullet that I shot, and then it should somehow deploy automatically. And with DevOps, everybody starting saying poo, poo, poo. And this poo, poo, poo is now being built around Terraform. as much as it is possible because it's quite useful tool set. Unfortunately, this toolkit has some birth diseases. And when I was drinking coffee, I thought that these birth diseases are compensated in the infrastructure. Not all of them, but some of them. And I thought one could delve deeper. And I found two things that can be easily integrated into your development as soon as you start using event-driven architecture approaches. Not all of them, but some aspects. So let's consider two problems with which you should start. At least you'll be able to see the solution in a very simple way. So the more your team is going to work on the architecture, the more difficult it's going to be with everything else, because we're keeping a certain state. Infrastructure is a file in a certain sense. So this may cause some problems with management. Should be done centralized. It has to be protected in some way. But again, we're running into the problem of syncing, aligning this whole story, because we have different teams. One needs to start, another one to wait. Some common pipeline needs to be maintained. So then the infrastructure needs to be analyzed, and everything should be in the same listing. But the more components there are there, especially if you have a well-developed infrastructure with lots of settings, you start dying, drowning in all these things. And as a developer, you don't want to do that at all. It's clear that we start fighting that with the state. We keep the intermediate state in S3 and the locked one in the database. So it's a temporary solution, but it works. Why not? So it looks like you have it stabilized in some way. But how does the event-driven architecture impact all this? What I liked very much when I started going through this was the statement of Adam Bellmer. He, as a staff technologist at Confluent, made a very interesting hypothesis that all more or less large architectures deployed gradually, step by step, not even understanding that, migrate to become an event-driven architecture just on the basis of the scope of changes accumulated in the system. You start using those approaches, not even understanding that you do. And a large part of this work is that when you're starting from in the modern microservice architecture, the systems exchange information, issuing and consuming events. So the whole looks right. We have service A, service B, there's some queue between them. I threw some data into that queue, then the system has read something from this queue. Does it make the system an event-based? Well, of course not. But if we replace a regular queue by Apache Kafka, because there are pipelines there, we can subscribe and unsubscribe, we get a fully pledged producer and consumer, then we seem to be getting quite close. Seemingly, we've just replaced some unknown queue by Apache Kafka, and nevertheless we get that. And a more noticeable change is in that we, largely speaking, in our infrastructure, identify conditionally independent components. We split our architecture in terms of sense, in terms of meaning. We can keep managing it through Terraform, but what do we get here? Conditionally independent components, because why? We have clear delineations in the login. So within the structure, you say, so here before this event, it's one thing, and after that, it's the responsibility of the platform team, for instance. And we get into separate deployment of service component. So it's just that we take this huge terraform that has been growing because independent teams have been working on it, not impacting each other, so that we're split through the events. So it appears that we have been able to unlock this tangle. There are a few technical moments here that we can discuss separately, but on the whole, with each team keeping the state in the database and the log state in my database, we get some order. From this, a certain order emerges. The system seems to have become more complicated, more complex. And one starts thinking, so it's not just a simple queue, the quorum, and updating is becoming a more difficult process. And on the whole, when you start building an event-based system, of course it becomes more complicated. And we run into problems related to the updating. We can identify three basic problems here. One about adding new services when a new team has built a new service. It's about updating of old services that are already running under load, that consume some data from this queue, and scaling of the system based on the growth of the load. So the infrastructure doesn't seem to have changed. It's just the size of the load has grown, and it may be just a regular seasonal load. But that impacts our systems and our infrastructure components in terms of deployment, I mean Terraform. So some problems with updating. It's manual intervention. If this is not good, generally speaking, if from the point of view of infrastructure as a code, we should take in everything into IIC and run it manually. This does not seem to be quite nice from the practical terms of view. But what if somebody has done something undocumented? So it becomes difficult to automate. Again, there's a problem with change reversal. If we do that, Terraform as such and most IIC components don't support automatic rollback. You need to do it yourself. And also, you need some additional effort to, invent these rollback strategies. And again, if we are limited in diagnostic tools, errors, so we don't quite understand how the current, what the current infrastructure is about. So what does EDA give us for updates? Then we get into the very interesting part. One of the basic properties of any EDA architecture
слабая связность компонентов.
to a certain extent is about loose connection between components. Why? Because they interact via events. If And unless I have read the event, they're waiting for us. It's a kind of a contract. In terms of a contract, it's about a commitment from the other side regarding how long they will be waiting for me. But nevertheless, the components, because the scope of the components is limited, they are independent in a certain sense. Of course, in a certain sense. And colleagues,
Я вижу, что,
I see that
если посчитать, наверное, здесь, тысячонка берется на всех.
you sum all of you together, you have 1,000 years of experience at least. Who has used blue-green deployment?
Там, вот тут еще.
I see people here. Yeah, super, cool. It's a classic pattern, isn't it?
Сам по себе паттерн.
And generally, this pattern as such has been known for a long time. The pattern of continuous integration and continuous delivery, CI/CD, which allows us deploying components smoothly and safely, migrating from the old version to the new one. Actually, this whole story considerably simplifies once we start using EDAs. And doing this, we also solve three problems of updating: traffic, data, and deploy. How do we do that? We have a consumer. of events. We have the events, meaning the incoming traffic. It's being accumulated somewhere in the intermediate states, and the system accumulates it before we can update it. More than that, we can use other ways we can take these events and start servicing them on parallel in order to make sure that everything keeps working, to provide for the gradual change of loading. And everything is happening in parallel. You need to read all the events. One of the properties of the architecture is that we don't destroy the event after processing. We keep it following some policy. Quite often, when you build a system, you archive these events, you load them somewhere so that if needed, you can replay the state of the position of the system, step by step, move by move. What happened? What changes were introduced? How this packet was processed? You can archive, you can save it for some checks. What that if we work on an event-based system, we can test our system for new workloads, because we have a pattern of the workload stored. It's clear that there may be different and a lot of different strategies. I'm not going to dwell on that. One of them from me about safe adaptation migration, and another from my colleague from T-Bank about zero data deployment and database. So my colleague has done a good job preparing that. In any event, several things are important that I'd like to mention. We automatically come to the use of event-based approach when we start developing the system, making its work more complex, and try to split it into two parts. Because there are lots of teams, there are lots of components, and you don't want to step on each other's feet while working. And these small changes related to the change of the limited context that we work with allow you changing the entire architecture. When you start thinking about a restricted context, then you recall stories about domain-driven design. It's an approach to software development, software design that comes in quite handy. There are three very good books. The freshest one comes from Vlad Kononov, and there are a couple from Adol Belma. The second one was released just last year. It's a great book. One is about microservices. The other one is about data meshes. Technically, it's a very simple story. All the bonuses from the interaction between the core and infrastructure codes are obtained by applying two things. Firstly, restricting the context of the components, and second, from the fact that we start managing the infrastructure through independent components, while all the well-known methods of infrastructure updating are applied. But the split allows us reducing the load, reducing the complexity, and improve repeatability. The problem is that there's a problem that we don't have solved here. The problem is related to the support of APIs from different places. It's like one of those bad things I would also like to add to our discussions. I wouldn't like to bypass this point. This problem has not yet been solved and may not be solved in the near future. Please raise your hands who use Terraform quite well, who can write modules, Terraform module. So I see some hands here, there. Great, super guys, thank you very much. It's really cool. So, take some component. For instance, I am taking some serverless app. I have some external supplies or events. Under the hood, I have some system that sends events to me. Of course, it's not an event-based system, but nevertheless, if I go really deep, I'll see that it's building blocks. Say those same building blocks that we're talking about. They're simple. They're limited to the structure of my app, and the smallest of those building blocks is usually a function. A piece of script, a script in Go, in Java, whatever, is just supported by my platform, can be run as a separate element. In terms of event-based architecture, it's just a regular classic component can be a consumer or producer that can supply some data to some queue, to some message processing platform. So how will I deploy it? I'll take classic Terraform and write down a listing, although how will I write it down? Here's a second listing, I'll need cover thing, third listing, fourth listing, and then I get tired. Look, it's just about 10 lines of code, so why should I put that? And colleagues are writing Terraform's module will tell me, Anton, look at me. Just write a Terraform module, so it should be quickly done, and everything should be processed immediately. Yeah, and what if I want to deploy this function, this component, this element of an event-based system in more than one provider? What if I have several present points, and you tell me, oh yes, you can write it for here, for there, and more than that, you'll probably have to write it inside the code, here, here, and here, and you'll write it in different ways. So everything will come apart, and I'll say, pum, pum, pum. But how can we do it somewhat differently? I wouldn't just like doing that. And how would you like to do that? I would like to do it in such a way so that I should just write it somehow once, and then it should somehow, evolve. And okay, it may deploy different ways in different places, but without me, so that it should go there. Yeah, but purely technically, this approach, it looks like it's being developed, and its infrastructure from code, IFC, 3 principles have been formulated. First, low ops. So we would like to have it as little as we can. So it should be comfortable for the developer, and so that it should be vendor-free. So that I wouldn't have to worry about that. On the one hand, we're all moving there. We're opening our APIs. We're trying to look from behind a shoulder from everyone, trying to do everything in the same way. And different the developers say that why don't we build some framework that would wrap around your code so that you could deploy it in a standard way. So a classic example comes here, Network.io. So you can take your app, there it be wrapped, and then with a plugin in the infrastructure code will be written, and different clouds will be supported, and you can write it yourselves. I mean, both the plugin and the adapter. In this sense, it turns out that I'm writing code. It gets automatically wrapped, and then I can deploy it in different platforms. But so far, it has been quite, rough and raw. So this wonderful dream, so that we should split everything into components. The components so simple that we could describe them fast in code, so that they could deploy as building blocks on any platform. We're not yet there. You, as developers, live not in the world of dreams, but in your specific platforms. It may well be that your company has its own platforms. And what do developers do? Will they be looking at what's happening in parallel and try to build it into your platforms? And so sooner or later, it will come to you. Some parts of serverless systems, some specificities of deployment. In any way, you'll be building your great spaceships. And of course, if your infrastructure is to grow, if the load is growing, if you operate with events, then it's quite obvious that you'll be migrating on this spaceship towards the core, the approach. And what next? And next, if you have the time and desire to always stay on the wave, I recommend to look at some of the materials that I collected under this link, paying special attention to the thing that I haven't mentioned in my presentation. What it's all about is that when we deploy the infrastructure in some cloud, we find ourselves in a situation where we start paying for it. Well, bloody hell, we as engineers don't want to touch this subject. And once DevOps does that instead of us, or on our behalf, I mean, some colleagues of us, we don't touch this thing. And it's quite important for us as engineers. The point is that FinOps as a discipline helps you assessing one other important property of your solutions. How expensive is your infrastructure and how expensive are those components that you're developing? EDA helps doing quite important things because the contexts are limited and you deploy components through it. You can do one of the simplest practices in FinOps, labeling of resources. You can, from the outset, mention which projects they belong to, for which issue they are, in order to collect analytics. You, as engineers, can take care of some aspects from the get-go. So if you familiarize yourself with my presentation under this link, you can get some ideas to this effect. With this, I would like to thank you for your attention. Thank you for raising your hands, and thank you for being part of this.
Обязательно приходите по QR-коду.
Please use this QR code, assess. Anton will take a great pleasure. I will be very happy. The program committee will be very happy because among all those who will have voted, a book will be drawn about Leslie Babbage. Please leave your contact details and we'll send everything to the winner. Okay, if you want to ask questions, please come up to the microphones. Come up to the microphones and shoot, ask your questions. And we are going to give a book from the Peter Publishing House for the best question. Okay? Okay. Okay. The light is glaring in my face. So please raise your hands for whom everything was 100% clear. Okay, not bad. All right. Please raise your hands who still have some questions. And why are you not at the microphone? Okay, I see you there. Hi. I wanted to ask a question about this subject. So if you're mentioning some specific words, Terraform, Kafka, is EDA an approach? So maybe we should say Kubernetes, and then we will remove vendor lock. It'll be about a transition between clouds. So why don't you add this word? Okay, thank you. What's your name? Dmitry. Dmitry. Thank you very much for your question. The important thing here, Kubernetes, on the one hand, I like approaching these components as an environment. Kubernetes actually is a platform within which you deploy your applications. And if you also believe it to be a platform, one of the platforms, so you can use your own platform, okay? You can build your apps on top of VMs. You can build them on top of codes within Kubernetes, but you will still face deployment issues. Again, it will be built around Kubernetes, automation tools. If you automate this whole thing using code, more likely than not, it'll be Terraform. I tried to fit Kubernetes in there, but I understood that I rolled back to the state. So you can take this as a standard. So you've taken Terraform as a standard. Why don't you accept Kubernetes as a standard? Because in that case, that would fit very well. So for those who are online, I'll repeat part of your question. If we take as one of the standard elements, if we use Kubernetes as one of the standard elements that will be carrying to every platform, one would think that we'll have the same platform everywhere. Actually, the maximum value of any cloud provider, where you go. So forget about anything. Forget that I work with Yannick's Cloud. You'll get maximum value at the moment when you start using the services adapted to this particular cloud, because that will reduce the load on your engineers, even if you start using some managed databases or queues deployed there, some other components. The more components you start using in a specific cloud, the lower the load will be on your development teams. As a company, you'll be able to move faster in terms of development and value deployment. So limiting it to just Kubernetes, you will make sure that your load becomes higher. It's a very strong restriction that you impose on yourself. You accept all the risks as your responsibility and support a point. So if you're living in a cloud, then you should take care of risk being shifted somewhere else. You can, of course, discuss what kind of risk can be delegated, but that's an important point. If you're prepared to take it up, why not then? Okay, the only thing I can't hear you very well. And I think that applies to everyone. I suggest that we continue discussing this one-on-one after the presentation. So next question. Thank you very much for your presentation. Very exciting, close to life. I would like to hear your opinion. How you, as a visionary of serverless and low ops, what do you think? What will be the place of low ops engineers in the future? Maybe they'll transform. Maybe maybe it'll turn into a different specialization. Maybe they'll get extinct. What's her name? Victoria. Victoria. I think there are three trends that we're seeing right now. Trend number one. It's about the automation of routine operations, put it this way. The entire toolkit that we see now is basically focused on automating routine operations. Unfortunately, this glue level between toolkits remains on the shoulders of the people. On the one hand, you have to set up automation, and on the other hand, you still do some, manual clicks, because seamless integration is not happening. So this is the place of DevOps engineers, people with deep expertise in DevOps practices. That's thing number one. Second is what I've been saying for the past 2 years. It's about an emergence of different sorts of AI agents that help DevOps engineers in their work. They help assist rather than replace them. It's an important distinction. It says your performance will grow. You'll be servicing more teams, more products within your ecosystem. That's the second part. So using these tools, you'll see your performance grow. Of course, there are subtle things there. You can discuss certain things, but nevertheless, this is the second thing. And the third thing that covers or completes this whole picture is related to the fact that over the past few years, we've been observing a move toward multi-platformity. So the approach where you don't live within the same cloud of one provider, but you have this infrastructure for this, and then you have another infrastructure for that. And the place of a DevOps engineer and for these specialists is very important. It's in the expertise of deployment in different environments, because the developer who's focused on implementing business logic, their expertise, it's all there. They can't you bridge this gap between different platforms. It will always exist, and you, with your expertise about that, you'll be able to embed this code into this environment, add the glue, so that a lot of different teams could, interact and scale. And that'll be your responsibility area, and then it'll be growing through the roof. Thank you. Thank you for your question. Okay, friends. Are we going to have more questions? No. There are questions. Okay, please come up to the microphone. And while we're waiting, let me remind you that this Saturday, in this very room, we'll run a programming Olympiad. Please come here, get registered. There'll be exciting tasks, problems presented. Thank you for your presentation. And now that we're at a security conference, my question will be like this. How the EDA approach matches such things as hidden potentiality, anti-brittleness, when a service is created and they don't change. And all the changes turn to complete redeployment of these services. Thank you very much for your question. I didn't mention one very important characteristic of serverless. It's the fact that you redeploy it completely. A new VM is created, a piece of code is put there, and it starts. And once a user request is sent, it is shut down. All the memory is flushed. Everything that was there, everything is deleted. And the next approach goes to the next VM. So it appears this way. If we have a system that supplies events, then actually the event always arrive at state 0. So this is a perfect state that we are moving towards. So this is the way for us to solve this question of getting rid of some remainder data. It's not always done this way. It's just a quality of those serverless systems. And it's one illustration how we start borrowing approaches from each other. So all this sort of with the serverless, with VMs, comes from there. You can immediately do it on serverless components of the same functions. There are a number of other components that work following the same principles. And then we get these characteristics from the outset. Otherwise, we have to bridge this gap manually in terms of secure development. I hope I've answered your question. Yes, thank you very much.
Есть ли у нас еще какие-нибудь вопросы?
Okay. Do we have any more questions? If you just try to ask a question in the microphone, Anton, you're not running away. You'll be able to catch Anton at the fringes and talk to them. So you now have this problem of choosing one question out of those great questions that you've been asked. Who's wrote the book? Victoria was here. Great. So, Victoria, great question. Okay, thank you very much for your question, for attention. Victoria, please come to the stage and we'll hand you the books. Thank you for your time. Thank you for your attention. Anton, thank you.